أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Today we are going to talk about percentiles and normal distribution. What is normal distribution? We have already discussed the properties of normal distribution. The properties of normal distribution include that this distribution is symmetrical. It has a bell shape. The median, mode, and mean takes the same position. It is continuous and it is determined by two parameters, mean mu and standard deviation sigma. Those are the properties of normal distribution. And what is percentile? What is the relationship of normal distribution and percentile? Percentile divides the data set into 100 equal groups. From P1 to P99. Percentile number 1, number 2, number 3, number 4. And it tells you the position where a person stands. For example, if a student takes a test of ETA or any other NTS test and his score is 70 or 75, what will be his percentile, his or her percentile? So if you know the percentile, you can calculate the Z-score, and from the Z-score, you can calculate the percentile of that person. And also, if a person is in group, a percentile, for example, the person is in 90th group, that he is having 90th percentile, what will be his score? You can also determine or calculate his score as well. Now look at the table, and we will be discussing one by one the percentiles and the normal distribution and the relationship and how to calculate percentile, from percentile the Z-score, and from the Z-score the percentile, and also the X, the score of the person, individual score from the percentile. So let's move on. Percentile or position measure used in educational health related fields to indicate the position of an individual in a group. Percentile divide the data set into 100 equal groups. At least n% of the data lie below the n percentile, and at most 100 minus n of the data lie above the n percentile. For example, 90th percentile indicates that at least 10% of the data lie above it, and at most 90% of the data lie above it. Now, let me explain the percentile with respect to normal distribution. Now, let's see, for example, this is a bell shape, a normal distribution. And percentile start from P1, P2, up till P99. It means that the percentile divides the data set into 100 equal parts. This half of the bell shape indicates 50th percentile. And how you calculate the Z-score from your percentile? Let's suppose if a student has 90th percentile, how can we calculate the Z-score? First, what you have to do, what is 90th percentile? 90th percentile means under this bell shape, from 1 up to 90, yani 90%, it means that 90% of the area has been covered by this 90th percentile by a person who is included in this 90th percentile in this group. So you have to convert this 90th percentile into percentage, 90%, then divide this into 100, which will give you the area under the normal curve, 0.9. it means that the total area under this normal curve is from 0 to 1. Total is 1. 0.9 means the area by this group. The person who is standing over here, he has covered the area up to 90%. So when we convert it into area, it becomes 0.9. So from here to here, this area becomes 0.9. Now, to calculate the z-score at this position, what should I need? I need this area. So what will I do? I will subtract this one area from the total area of 0.9, which will give me the area from the center up to this 90th percentile. So 0.9 minus 0.5, this is equal to 0.4. So the area from this midpoint at 50th percentile up to 90th percentile is 0.4. Now the next step is to look into the Z table. To look into the Z table, this area, you have to look this area into the Z table, where it locates. The area 0.04, you have to see the row and then the column. In the column, you have to see to look for the Z value. And in the row, you have to look for the second value. I mean, where this area locates. Like if it is under 0.08 and 1.28, I'm just assuming. So what you have to do, you have to add up these two values, 0.8 and 1.2. So it becomes 0.08, 1.28. Now, if this area does not exist anywhere in the Z table, then what you have to do, you have to look for the nearest area, which is nearest to the 0.4000. So this area 0.4000 does not exist anywhere in the table, and the nearest area is 0.3, 9, 9, and 7. Now you have to look for this area in the Z table, and the value above this area, above 0.997, which is 0.08, and in front of the value, which is 1.2. So you have to add up these two values, which becomes 1.28 and 0.08, and that becomes 1.28. So from percentile, you have calculated the z-score. I have just assumed the area or the values may be different, but you have to look this area in the Z table and the upper value where this area locates, the upper one in the row, and the against value in the value column, and then you have to add up these two values. That will become the Z-score for this specific percentile, 90th percentile, and so on. You can calculate the Z-score for 85th percentile, for 50th percentile, for 30th percentile, and for 40th percentile, and so on. Now, look back into the, go back into the slide and see what I have on the slide so that we can further go ahead. Percentile of normal distribution. In order to compute the percentile of a normal probability distribution, first we need to learn the computation of percentiles of the standard normal distribution using the standard normal curve. Suppose Z has a standard, this is one of the good example of standard normal distribution and the percentile. Suppose Z has a standard normal distribution, find the 84th percentile of this distribution. So what I have done on this slide, first the 84th percentile, you have to convert it into percentage, because a person who is included in the 84th percentile, he has covered an area from 1 up to 84th, mean the 84% of the area has been covered by this group, and whoever is included in this group, he has covered the area of 84% under this normal curve. So from here to here, this is an area covered by 84 percentile. We have converted this into percentage and then divided by 100, which will become 0.84. And we need an area from here to this z-score. So we have to subtract 0.5 from 0.84, which becomes 0.34. And then you have to look 0.34 or 0.3400 in the z table. And where does it locate? The upper one value in the row and the against value just opposite of this area, the value in the column. You have to add up these two values, that will become the z-score. So here the area 0.3400. I'm just looking for this area, whether it exists or not. If it does not exist, so the nearest area is 0.3413, and this locates under 0.00 and 1.0. So the z-score over here is equal to 1. Let's move on. Find the 50th percentile or the median of the standard normal distribution. The 50th percentile locates just the mid of this curve, 50th percentile. And here the z-score is 0. The reason is, if a person is included in the 50th percentile, his percentile is 50th, means he has not moved from this midpoint either to the right or to the left. So the z-score will become 0. Whenever you move to the right or left of this midline, then there will be a different z-score. But for this particular 50th percentile, the z-score is 0. Let me explain it further. Look. Just have a look at this curve. This is the 50th percentile. This is the 50th percentile. Now what you have to do for a z-score, you have to subtract this area 0.5 from which one? From 0.5, because this person has not moved either to the right or to the left. So you have to subtract 0.5 from 0.5 and it becomes 0. So the z-score is equal to 0. So whenever, remember one thing, if you have, if a person falls in the 50th percentile, definitely his z-score will be 0. It is understood. If it comes in the MCQs, you have to answer straight away. If a person stands on the 50th percentile, what will be his z-score? His z-score will be 0. And his individual score X will be equal to the mean of this score, whatever the data is given in the scenario. Let's move on. Find the 16th percentile of this distribution. So what you have to do exactly in the seminar is I did in the previous slides. 16th percentile is converted into percentage, then it is divided into 100, and or you can do you can also go for this one as well. You have to subtract the 16% from 50%, that becomes 34%, and then you have to divide it on 100, so it becomes 0.3. Sorry, you are not supposed to directly convert 16 percentile into percentage. The reason is this 16 percentage falls below the midline. So for this, what we have to do, first we have to subtract this 16% from 50%, that will become 34%, and then the 34% will be divided over 100 and it becomes 0.34. The 0.34 area is from this midpoint up to this one. And what will be the z-score? If the percentile, it is less than the 50th percentile, and the z-score will be at the left side, and that will be with negative symbol. So the z-score over here would be -1. The reason is 0.3400 in the z table, it carries a z value of 1 if it is on the right side, and if it is on the left side means it is less than the mean. So you can you will put minus or negative symbol with the z-score. So that will become -1. Suppose the reaction time of particular drug X has a normal distribution with a mean of 10 minutes and a standard deviation of 2 minutes. Find the 50th percentile or median reaction time. What will be the 84th percentile of the reaction time? First, we have to calculate how the individual score is calculated from the z-score and from the percentile. So first we have to learn this. Z is equal to x minus mu over sigma, or x minus mu over sigma is equal to z, or x minus mu over sigma into sigma, if you want to cut it, is equal to z into sigma. Whatever you do with this side, you have to do this with that side as well. So here it is gone, is equal to zq. So x minus mu plus mu is equal to zq plus mu. Now this is the formula for calculating individual score from a z-score or from percentile. If you are given mu, standard deviation, and z-score, or if not, if you are given percentile, the sigma and the mu, you can calculate z-score from the percentile and then put the values of sigma, mu, and z, and you can calculate the x from this formula. Now, what is the data over here? Find the 50th percentile or median reaction time. What will be the 84th percentile of the reaction time? And the mean is 10 minutes with a standard deviation of 2 minutes. So we have to extract data first, and then we will go for the solution. So the data over here is mean is equal to 10 minutes and a standard deviation is equal to 2 minutes. Now for 50th percentile and then for 84th percentile. For 50th percentile, we have already discussed, then at 50th percentile, the z-score is equal to 0. So what will be the reaction time, means what will be the x. And for 84th percentile, what will be the z-score and then the x, z and x. So first we have to calculate the z-score. It is understood that on this midline, the z-score is equal to 0. So putting in the formula for this 50th percentile, x is equal to zq plus mu. So z is equal to 0 and sigma is equal to 2 plus mean, which is 10, and that becomes 10 minutes. And I have already told you, as I have said, that a person who is included in the 50th percentile, in a group of 50th percentile, his individual score will always be equal to the mean. The mean over here is 10 minutes and the individual score is also 10 minutes. The reason is this person is standing in the 50th percentile. So here the z-score is 0. So putting in the formula, we will get the mean score for individual. And for 84 percentile, now the 84 percentile is over here. This is the 84 percentile. If you imagine, draw an imaginary line, that becomes the position becomes over here for 84 percentile. We need this area so that we can calculate the z-score from the table and then x. So the area from here to here is 84% divided by 100 is equal to 0.84 minus 0.5, that becomes 0.34. That becomes 0.3400. And in the table, this area carries a z value of 1. So the x will be, it is 1, standard deviation 2, and plus 10. That becomes 12 minutes. I have assumed that it carries a value of +1. It may be 0.98 or 0.99. So you can put this value in place of z-score, and then you calculate, so that will become 11.98, something like that, which is almost equal to 12 minutes. So this is for 84 percentile, the z-score, and then the individual score x, that becomes 11.98. What does that mean? That a person who is standing at 84th percentile, his individual reaction time, the drug which will react on this person will be after 11.98 or after 12 minutes. Now move on further. This is the solution, how you have to calculate the x, the individual score, and the z-score. Suppose the age in a population is a normal distribution with mean 60 years and a standard deviation of 10 years. Find the 70th percentile of the variable age, find the 85th percentile of the variable age, and find the 30th percentile of the variable age. So here, the mean and the standard deviation are given in the scenario, and you have to calculate the z-score from 70th percentile, from 85th percentile, and from 30th percentile, and accordingly you have to put in the formula and then calculate the individual score who is standing on 70th percentile, 85th percentile, and 30th percentile. So let's do it. Let's do it on the board. Mean is 60 years, standard deviation 10 years. And what you have to do, you have to find x for 70th percentile, for 85th percentile, and for 30th percentile. So let's do the first one, the 70th percentile, and then 85th percentile and 30th percentile respectively. So x is equal to z cube plus mu. On 70th percentile, it will fall over here, 70th percentile. What you have to do, you have to convert it into percentage, 70%, and then divide it by 100, which becomes 0.7. So the area from here to here is 0.7, and we need this one area. So what we have to do, we have to subtract 0.5 from 0.7, that becomes 0.2. 0.2000. Now we will look this area in the z table. If it exists, we will look for the upper end against value, and we will add those both values, which will become the z-score. And if it does not exist anywhere in the z table, we have to look for the nearest area. Now let's see first the area. 0.000. So I don't think 0.2000 is anywhere in the table. 0.1915 and 0.21, 0.2019 and 0.1985. 0.1985 is the nearest area. It is the nearest area. 0.1985, and it falls below 0.02 and 0.5. So when we add up both the values, that becomes 0.25. Let's come back to our calculation. So this area is equal to 0.1985, 0.1985, and the values are 0.02, and the front value is 0.5. So both become 0.25. 0.52, sorry. 0.02 plus 0.5, that will become 0.52. This is the area of Z. Now putting these values in the formula, X is equal to Z 0.52 into 2 into 10 plus 60. And that will become 5.2 plus 60. So that becomes 65.2 years. So a person who is standing at this 70th percentile and the mean age is 60, this person will carry an age of 65.2 years. Now let's go for the other one, for 85th. The 85th percentile will locate over here. Over here. What you have to do, first convert into percentage, then divide it by 100, so it becomes 0.85. And then what you have to do, you have to subtract 0.5 from here so that you can get an area from here to here and to calculate the Z-score. And then the X. And this will become 0.35. 0.35. Now we will look this area 0.3500 in the Z table, and we will determine the Z value. So 0.3500, 0.35, 0.3508, which becomes the nearest area, 0.3508, and this area falls below 0.04 and 1. So it becomes, when you add up both the values, it becomes 1.04. 1.04. So X is equal to, the Z is equal to 1.04 according to this. This area actually does not exist in the Z table. So we will go for 0.3508. This is the closest or nearest area to this one, and it falls below 0.04 and in front of 1.0. So both will become 1.04. Putting these values in the formula, it becomes 1.04 into 10 plus 60, and that will become 10.4 plus 60, 1.04 multiplied by 40 1. After 2, so 10.4. So 10.4 plus 60 is equal to 70.4 years. So a person who is included in the 85th percentile, his position is 85th percentile, his individual age, score or age will be 70. So here the variable is age, so the individual score will be 70.4 years. And similarly, you can calculate the next one as well, which is 30th percentile. Here the scenario is somehow different because 30th percentile falls below the midline. So we will also do this. Now look at the calculation. '30th percentile will fall somewhere over here. Somewhere over here. Now what you have to do, here is the 50th percentile. So we are dealing with this area from here to here. The total area is 50th percentile, mean 50%, and 30th percentile has got 30% of the area. So from 50%, you have to subtract 30%, and it will become 20%. It will become 20%. So the area from here to here is 20%, or 0.2. If you divide this on 100, that will become 0.2. Now look, the area of 0.200. I don't think this area exists in the table. We will try what we have in the table. The area 0.200. 0.2000, it does not exist somewhere else. Okay. So 0.1985 is the closest area, and it falls below 0.02, 0.2, and in front of 0.5. So the Z score will become 0.52. It will become, Z will become 0.52, but it will carry a negative sign. The reason it falls below the midline of the 50th percentile, so the Z will carry, the Z value will carry a negative sign rather than a positive sign. So putting in the formula, minus 0.52 into 10 plus 60, and that will become minus 5.2 plus 60. So that becomes 54.8 years. So a person who is having 30th percentile, who is having a position on 30th percentile, who is included in the 30th group, the individual age of this person would be 54.8 years. Now move on further to make your concepts clear about the normal, the percentile and the normal distribution. If a set of score on an epidemiology examination are approximately normally distributed with a mean of 75 and a standard deviation of 5, what is the 35th percentile of the variable score? What percent of the student who take this examination score at most 80, and what percentile is score 80? What percent of the student who take this examination get a score at least 90, and what percentile is score 90? Now the scenario is somehow different from the previous one. Here, the mean and standard deviation are given in the scenario, but the questions are different from the previous one. Here you have to calculate the individual score, and for the individual score you have to calculate the percentile of that person as well. So we are required to calculate percentile from the individual score, and from the percentile we have to calculate the individual score as well. Now let's have a look. The mean is equal to, see, the mean is 75 with a standard deviation of 5. Mean is 75 with a standard deviation of 5. Now I am noting other, extracting the other values, the data as well. For the 35th percentile, percent of student who take this exam score at most 80, and the percentile on 80 score, and then score 90, and what will be the percentile. So for 90 score, the x is 90 and you have to calculate the percentile. Now mu is 75 with a standard deviation of 5. Now we have to go for the calculation. The mu is 75 with a standard deviation of 5. First, you have to calculate x for 35th percentile. Let's do the first one. The 30th percentile would be somewhere over here below the 50th percentile. This is the 50th percentile. Now what you have to do, you first have to subtract from 50% the 35th percentile, which will give you the area from the mid up to 35th percentile, and that becomes 15%. So the area, and if you divide it, it will become 0.1500 in the Z table. This area is 0.1500. Now look in the table, the area of 0.15, what Z value it carries. So 0.15, 0.154, 0.157. So the closest, the nearest area is 0.1517, which is below 0.09 and 0.3. So it becomes 0.39. It will become 0.39. This area, the value for this area is 0.39, but as the value falls below the midline, it will carry a negative sign. So you will put the negative sign with this Z value. Now putting in the formula, you will get ZQ plus mu, and that will become minus 0.39 into 5 into 75. So that will become 5 9s are 45. 5 9s are 45. 5 3s are 15 plus 4, 19. Minus after 2, 1.95 plus 75. And that will become, when you subtract 1.9, 1.95 from 75, that will become sorry, yes, 75. This is 75. So 5, 9, 74, 7. 5, and this will become minus 0 and 74. So a person whose position is 35th percentile, his individual marks will be 74.05, where the mean is 75. So this person falls below the mean. Now go for the other one. Let's move on to the other question, which is a person who has scored 80. His individual score is 80. how many students will get marks at most 80, mean 80 and below. So first we have to calculate the x. First we have to calculate the z-score from the x, and then we will go on percentile. X minus mu over sigma. Why do we calculate z over here rather than x? The reason is x is given, mu is given, standard deviation is given. First we have to calculate the z-score. If we want to calculate the percentile, we should have the z-score so that we can look up the area. We can look the area in the z table, and accordingly we have to calculate the percentile. So the z-score will become 80 minus 75 and then 5. So that will become 5 upon 5 or plus 1. Now the person who has got 80 marks, his z-score is plus 1. So find the percentage of those students who have got 80 and below marks. 80 and below marks. For this, what we have to do, we have to look this z value in the table, the area for this z value. So let's do it. For 1, the area is 0.3413. Area is 0.3413. So the area over here is 0.3413. And what do we need? We need an area from here to here so that we can add up and then convert into percentage and then into percentile. So the area from this area to this midpoint is 0.5. When you add up these two areas, that will become 0.8413. If you multiply this with 100, you will get 84.13%. So the person who is having a score of 80 and his z-score is plus 1, his percentile is percentage, the area that he has covered up to this point is 84.13%, and just delete the percentage sign and add up or put the TH sign. That will give you the percentile. So this person is having 84.13 percentile. This is an easy way how to calculate the percentile from x, mu and sigma when z is not given. You have to calculate first the z and then accordingly look the z value in the table and the area against this value, then add up. It depends upon the situation, whether the percentile is below the 50th percentile or it's above the 50th percentile. If it is above the 50th percentile, you have to add up. If it is below the 50th percentile, then you have to subtract accordingly. Now do the other one. A person who has 90 marks, a person who has got, let me check it first. What percent of the student who take this examination get a score at least 90 and what percentile? Now first, the student at most 80. If x is 80, what will be the percentage of those students who will get below 80 marks? So that becomes 0.3413 plus 0.5, and that will become 0.8413. And if you convert into percentage, put a sign of percentage. So that will become 84. If you multiply with 100, that will become 84.13% of the student will get at most 80. Yani 80 and means 80 and below marks. And now the last one is, what percent of the students who take this examination get a score at least 90? At least 90 means 90 and above marks, 90 and above marks. So now let's do it. Let's do it. X is equal to 90, mu is equal to 75, standard deviation equal to 5. Now first we have to calculate the z-score, because for determining or calculating percentile, you need a z-score so that you can look the z value in the z table and against this value, the area in the z table, and that is necessary for calculating the percentile. So x minus mu over sigma, this is equal to 90 minus 75 divided by 5, and that becomes 15 divided by 5, which becomes 3. So the z-score is 3. Now just locate this z-score. The z-score is over here. Z is equal to 3. Now we have to look for the area against this z value. So let's do it. .3. Sorry, 3. So against 3, the area is 0.4987. The area is 0.4987. So this area up to 3, the area is from here to here, 0.4987. It is the area for number of standard deviation 3. For a z-score of 3, the area is 0.4987. So what is the percentage of those students who will get above 90 marks? Above 90 marks. Now the total area from here to here is 0.5. For obtaining this one area, you have to subtract this area from 0.5. 0.4987, and that will become 3, 1, 0, and 0. If you multiply this with 100, because you are converting into percentage, the percentage of student who have got more than 90 marks, 90 and above. So that will become 0.13%. So the student who will get at least 90 marks, their percentage is 0.13%. So this was all about the percentile. You have to give your feedback about the strength and weaknesses, and if you find anything that is not clear to you, or the method, if you want any other strategy that will improve your skills of calculating percentile, your z-score, and the individual x-score, you can better give me a feedback, your positive feedback. Your feedback will be appreciated, and thank you very much.